So this unit is a little bit different than the ones we've done previously. There really isn't anything new to calculate or to go over as far as the math goes. What this unit is doing, it's laying the groundwork for the rest of the course. And by the rest of the course, I mean the rest of the course. All right, we are now moving into the transition of inferential statistics, where we're trying to take our data and draw conclusions about it, not merely describe it. And that's the rest of the course. And the foundation we learn here, we are going to apply to everything we do moving forward. We're introducing the 5 steps of hypothesis testing, and we are going to continue to do those 5 steps from now to the end of the course. So this is more sort of a preview of what's to come, beginning to work with some of the concepts. So again, there's not much new to calculate or even to think about, except introducing the core of this logic. So being able to recite and summarize those 5 steps is one of the main things I want you to be reviewing carefully in the text and coming prepared for in class. Right? The first step is to be able to state the hypotheses of the research project, both what we call the null and the alternative hypothesis, determine the parameters and the characteristics of what we call the comparison distribution, what we are going to be comparing our data to, determine your thresholds. Right? This is where we're going to make the decision that whatever results we found are significant enough that we think there is something there or not. Calculating our core test statistic, and lastly, making a decision about our hypothesis, specifically our null hypothesis. Right? So those are the 5 steps. You're going to want to read through them carefully. Right? The first one is determining the hypotheses, your null and your alternative hypothesis. The null hypothesis is, what is your hypothesis if there's nothing interesting going on? There is no difference. There is no effect. Nothing is happening. Any difference in my data and what I'm comparing it to is purely by random chance alone. Your alternative hypothesis is that there's something different about my data. It's bigger, it's smaller, it's slower, it's faster. I expect it to change in some way. That's my research hypothesis. You should be able to generate a null hypothesis and research hypothesis for any research description. The parameters we're talking about in step 2 are, what are the parameters of our comparison distribution? That's going to be our null hypothesis. What we're always going to need is, we're going to need 2 primary parameters, the mean and the standard deviation. Sometimes the variance, but the main things we're going to need to know is you got to know the mean and the standard deviation of the distribution we're comparing to. Because as we talked about in the last unit, mean and standard deviation describes the distribution. It is the mathematical description of the distribution. We need to know those 2 parameters. Step 3 is being able to choose a probability, right? This is the z-table that we talked about in the last class. This is where we go to the back of the book, and now instead of looking up a z-score and its corresponding probability, we are going to go to the back of the book and we're going to look up a probability and find its corresponding z-score. Let's take a look. So if I want to say that my cutoff, my threshold is 10%, if the probability of my data is 10% or less, then I think there's something interesting going on, then I need to find my probability of 10%. So I just look on the z-table, I go to the percent and tail, and I find 10%. And what I find is that would correspond to a z-score of 1.28. That means my threshold, my z-threshold, is 1.28 for a probability of 10%. So if my z-score is bigger than 1.28, then or more extreme than 1.28, or negative 1.28 if we're looking at the reverse, less than, then I can say that that there's something significant going on. All right, so that's step 3. And then finally, we have calculating the test statistic, which is just finding the z-score in this case, and then lastly justifying what we're doing with the null and alternative hypotheses. We're going to spend some time in class talking about what it means to determine whether or not a null hypothesis is true, or even if an alternative hypothesis is true. We're going to work through some of that logic. We're going to work through examples of z-test, but the main thing you need to do come into class is you want to carefully read about those 5 steps of hypothesis testing. You should be able to summarize them. You should be able to summarize them without looking up in the book. You're going to want to know those 5 steps by heart, right? And be able to generate a null and alternative hypothesis for any research description, determine your parameters, and then be able to use the z-table to find a z-threshold based on a probability. I'd be able to do those things. You're ready for class, and I will see you there.